Okay, so first of all, my name is Maoz Tamir. I've been working with artificial intelligence and machine learning for the last 9 years. And I'm going to talk to you about creating smart applications with machine learning. Just a quick check, anyone worked already with MLKit, TensorFlow lite? Oh, these two guys, okay. So we'll start from the basics. We'll start with something simple, which is trying to understand what you are seeing here. The first one will win some kind of a prize, okay? So just shout out if you guess what's in the picture. Yeah, you're good. Okay. So this is actually the Mona Lisa, and the reason I'm taking the time to wasting your time in analyzing this is because this is what actually is the base of artificial intelligence and machine learning, basically in machine learning. It's defining patterns. And our brain is pretty good at that, and it took us quite a while to teach computers to do that. And when I'm talking quite a while, artificial intelligence as a subject started on the early 50s, late 40s, early 50s. Alan Turing wrote a book about that, and then it had some kind of a dark age until the 80s, basically because we couldn't take the aspect of creating something that resemble a neuron, and we didn't have the computer power to do that. And in the 80s, we started with machine learning. Now, there is a difference between machine learning and deep learning, and I'll try to make it very simple to understand. In machine learning, we're trying to predict something based on features that we know that are defined in the subject that we are checking. Let's say we are looking for some kind of okay, let's think about the picture that we saw before, and we are trying to understand what's actually in the picture, so we can try to define what is the closest pixels, and try to understand from that. And we're actually doing some kind of a filter illumination in our mind. Deep learning is actually taking that step further without understanding the actual features, and let the computer understand the feature itself. And the computers are becoming quite good at that. And this is the actual leap between machine learning and deep learning. Okay, so first of all, let's just go over a few basics in what we did till now in trying to find a solution to some kind of problem. If we had some kind of an issue or some kind of a task that we need to resolve, we started with developing an algorithm, and then we implemented it, put in some kind of data, and we got a result. Now, the shift in this way of thinking is that today we are giving the actual data to a machine, and we are getting putting some kind of a data and the results, and the machine itself understands how to predict or to give us the result in the future. So basically, this is the change between traditional programming and machine learning. Now, I'm not saying that traditional programming is going to go away, because for many things and many situations, we will still need to use it. And there are many places that you are trying to push machine learning into the program by force. But you need to understand that this is a tool that today you have. If you have an algorithm that you want to create, which is based on a lot of data and a lot of examples that you have, you can use machine learning to implement that, and it is easier than you think. So why do we actually want to use machine learning in our applications? Well, first of all, to do what we always do is to add value to our applications. If you think about an application that translates, if you can take a picture and translate something instantly, it's much more easier for the customer to use it. The second thing is, think about this device as something that gathers a lot of information about you. It's actually a device that's full of sensors. It knows exactly where you are. You get voice, can record your voice, can take pictures, can know exactly in what situation are you moving now, in what speed. And this is actually some kind of a sensor tracker that is always with you. And this information can be used to give you some kind of a benefit. Let's say you want to create an application that knows if you are running or walking or driving. Okay? Now, in regular issues, if you want to do that, if you try to do it through an accelerometer or you try to do it through a GPS location, you're going to have issues because you cannot always predict that. But if you are using some kind of letting the machine understand by giving it parameters of the current accelerometer, current GPS process, and then understanding itself how, in what situation exactly the customer or the user is now, this could help. This could resolve your problem. And this is one example that is widely used. Searching experience, which is something that usually is not considered connected to machine learning, but in many ways we can understand through people in the area what they were looking for and try to create some kind of a prediction of what the person in a specific area will look for in some kind of a search that he's doing. And Google is using it today. And of course, everything in regards to detection and analyzing faces, what Apple is doing with facial recognition to log into your device. This is something that can be done today pretty simply in an application, in the device itself. Okay, so first of all, let's try to see what we have today, and if we are looking for some kind of a solution or some kind of capabilities that we have in the market today. And the first thing if we have some kind of a task that we want to implement is see what we have out of the box. Well, most of the major companies have some kind of a solution. If it's Microsoft Azure, if it's Amazon, Google MLKit, Alibaba have a great cloud service. And most of them have some kind of services that you can insert text and get translation, insert pictures and get some kind of labeling on the pictures. But I'm going to concentrate on MLKit, which is from Google, because it's had a few features that are, I think, a bit helpful for Android developers. First of all, it's based on Firebase, and most of us are already connected to Firebase in our applications. It has the capabilities which I don't see in other frameworks currently, that you can connect to, you can work on the cloud as some kind of a REST service, taking a picture, send it to the cloud, and get it back. But also have the capabilities to run on the device itself, running the actual prediction on the device itself. And out of the box today, you can use all these capabilities now, which is face detection and barcode scanners and landscape detection and image labeling. And currently, they also were added actual image object tracking, which is also available. But this is something which is very generic. These models are very generic. That means that if you are talking about label image classification, which use labels, you first need to make sure that the labels that you are looking for in your application are there. So if you want to detect a chair, you probably can use that and detect a chair by using MLKit. But if you are trying to detect something which is a bit different, you need to find some kind of a solution. Now, why do I really I really think that working offline is very important. This is from a few reasons. One is cost. Going on back and forth to the server is very costly in terms of time and in terms of money. If you are trying to create something that can predict what you are seeing now, and it's going to take a while to go back and forth to the server, it's an issue. If you are talking about translation and you don't have Wi-Fi or mobile connectivity now, you're going to get stuck. Getting out of the airport, opening your computer, you are still not connected to the network, and trying to translate a sign, that's going to be a problem. Also, the one thing that in the last year we see a lot is the issue of privacy. Remember that each time you send some kind of information, image, or voice to the server, it's going to be kept somewhere. You don't know who's going to keep that information and how he's going to use it in the future. So this is something that becomes really important in the last year, especially after the Facebook affair. Okay, I'm going to show you a few things on what you can do now. And this is actually, this is thanks to the guys in MLK team in London. As you can see, here we have an actual object detection. So you detect the object, and you can see it's some kind of a shoe. And this is the actual detection is done offline. And if you are searching for something, this is the only place that we are actually going to the web and trying to find the match. So basically, the architecture of this solution is a detect and track the object, and the actual base classification is done on the device itself without any connection to the web. And the actual cloud search, finding the specific or the similar object, is done by the Cloud Vision product, which is actually some kind of a search tool that you can enter a picture and get information about this object. Okay, so actual benefits that we already discussed, which is it's built why to use MLKit, which is built in building ML models. It works on cloud and device, and of course it's Google-based, so it's very scalable. And this is something that's very important when you come to a lot of people that are using your application. Okay, so let's go to the code and show you how easy it is to connect it. As you can see here, which is a bit small in mouse. Okay, as you can see here, we only need to connect to the. I didn't put in all the bits and pieces of adding to the Gradle and all that, but you. Sorry. Okay, you can connect to the Firebase Vision prediction, and you can either use the cloud identification or the cloud labels or on-device labels, which means that if you're using the cloud labels, you've got about 40,000 different labels. If you're using only the on-device labels, you've got about around 10,000. And of course, you can switch between them. I mean, if you are connected, you can use this, and if you're not connected, you can use that. And then the only thing you need is to send the image and get the labels back. And then just go over the labels, and it brings you back the label name and the prediction. Remember that almost everything in machine learning is based on prediction. I mean, I'm sending some kind of a picture, and it predicts, is that a book, a cat, or a dog? Okay? Okay, now, I wanted to create something that's a bit more specific and recognize something that wasn't labeled yet. I wanted to make it run offline, so I wouldn't need to connect to any web server or cloud. Okay, I wanted good response time, so I needed to run online and give predictions very quickly. And I also consider the cost, because remember that every time you're using that, somebody's going to get paid, and it's going to be very hard to predict it in the long term. So that becomes very costly to use these APIs. So first of all, my goal was to create something for one of the features that I like. Anyone is a Doctor Who fan here? Only two. Oh, that's a shame. Okay. Everyone knows who Doctor Who is? Okay, that's one. Okay, so the ones that does, okay, it's going to be a long talk. Okay, so the one that doesn't know who Doctor Who is he's a figure that comes from another planet. He's traveling around in a spaceship called the TARDIS in time and space. And once every season, he changes his figure, and he's usually not very oriented when he does that in the first two episodes of the season. So I wanted to help him, and this is actually his arch enemy, the Daleks, and I wanted to do something that will help him to identify them when he is in this Ouija state. Okay, so of course it have to be offline, and of course it have to have a good response time, and you cannot. I don't think Google did ever try to label Daleks in their database, so and that's it sets. So that's going to be an issue. So I need to create something very specific. Okay, so how do we approach that? Well, in this situation, we'll need to create our model ourselves. And today we have a lot of ways to create models and create actual machine learning models. And most of the names I think you already know: TensorFlow and scikit-learn and Coffee and PyTorch. I personally really like TensorFlow because, first of all, because of the capability to scale. It's a Google product, so it's very connected to Android, and it's very easy to implement, in my opinion. Okay, so we decided to use that, and we started to create our model. So first of all, when you are trying to create some kind of an image model or something that need to identify some kind of an image, we usually start to collect that data. And there are two tricks how to collect data. I don't want to go over and try to start to take pictures. And you need the data to be at least a bit, use a few examples of what you are trying to predict. Okay, so don't take only a picture of your cat if you want your application to identify cats. So I used two neat things that can help you with that. FatCan, if anyone knows, it's a very easy plugin to Chrome, help you collect images from your search page. Just download them. MPEG is a very, very old tool, but very helpful. You can actually take a movie of something, okay, just a quick clip of an object, and it actually creates a single picture from that, okay? Just cut it to slide, and then you can use that as a training material. So that's the first thing that you need to do. After you collect your data, and I'm not going to go over all the details here, this is going to be a bit conceptual, but there are many tutorials on how to do that in the web, and I'm going to release my solution on GitHub so you can use it. The second thing I took, TensorFlow, and use it to retrain my network. Okay, I'm going to remember this retrain issue, and I'm going to go back to that in the next slide. The third thing is to optimize your model, because when you create a model on TensorFlow, it's actually a bunch of 32-bit numbers that define the weights and define the network. And this is a bit heavy to implement on an Android device. But we have a solution for that, which is TensorFlow Lite, which transfer this model into something that can run on the device itself. Now, the retraining have to be, today, is done on computers. The reason new approach that Google is thinking about in adding to TensorFlow the ability to, or adding to TensorFlow Lite, the ability to do some kind of retraining on the device itself. But I think it's going to be out in about 2 or 3 months, so it's a bit early. And the last thing is to run it on the device. And we use, again, the API for TensorFlow Lite to do that. Okay. So remember I talked about recreating the model. The model that we are usually using for identifying pictures is called CNN. Stands for Convolutional Neural Network. I'm not going to go in details in this session because it's a very, very long and very complicated, not very complicated, but very, very long subject. Okay? But basically, we are feeding some kind of a set of pixels into the network. It starts with defining the labels, okay, the edges, okay. We are putting the pixels into the network, at first it starts to define a very, very simple shapes, and then it starts to find a more complicated shapes, and then you get the actual objects. And then you can just define which object is it, okay? Is it a cat, is it a dog, is it a Dalek, okay? Now, training this kind of a CNN network from scratch is very, very expensive, but and it's going to take days, hours, weeks, months, depends on your computer. But there is something that is, there is one feature that we can use to our advantage in neural networks, especially in CNNs, but not only in CNNs, which is, as you can see here, the first actual layers of this network, and when we identify the basic shapes, are pretty similar. So what we have to do is just train the upper layers. And this is called transfer learning. It's a very common practice in machine learning, in deep learning. And this helps us take in a data set or of specific labels that we want to identify and actually create a network in half an hour or an hour, depends on your computer, instead of days. So, and because these are the same, everything that the previous network or the original network already trained on, you can actually use that to your advantage, and then just you need to train the upper layer. Okay? So we're going to use this monstrosity, which is an exception V3 layer. You can use many other networks. It is one of the networks that works pretty good, or one of the models that works pretty good on mobile devices. There are others that, and this changed about once a month. There is a new change. As you can see here, and I'm going to, okay, this is the actual input. Okay, the network starts here. You see these layers, which is actually identifying the specific features. Okay, and we're only going to deal with changing this. Okay, so we're going to change this layer, and then everything that goes out is classified. Is this the Dalek, or it's not the Dalek? Okay, and give us some kind of an estimation. So the next step is creating my data set. I try to create some kind of I've collected all the data. You need to do some kind of a transformation to the data, so the retrain process will actually understand it. We usually do that in Python. Okay. Any of you that want to go into deep misery can try to do it in C++, but I don't think you should do that on your if you are still sane. Okay, so don't try to implement the C++ method. TensorFlow has a Python API, which is pretty easy to use. If you don't want to deal with building a specific computer for that, or trying to start to install all the necessary things that you need, you can try to connect to Colab. Anyone knows Colab already? Okay. Okay, so just go into Google Colab, And this gives you an actual notebook that you can enter Python commands and run it. It have TensorFlow already reinstalled, pre-installed. It have you can switch to a GPU if you want, and this is free of charge, and it saves your code in the cloud, which is very easy to use. I'm going to add the link to that also. Okay, so after we train the model, we actually need to load it. Here we can see a tool that is called TensorBoard. During your training, you can actually see if you got some kind of, if the model goes, trains okay, and you can see here that's the, sorry. Okay. Okay. You can see here that the training is going up in a steady rate, and you see the validations also, because we're using training from the training material, the training data, and the validation to validate that our training is okay. And if you see that kind of graph, you're usually on the right path. Okay? Okay. Remember I told you that we need to convert the model to something that we can use in the actual Android device. So TF Lite do it pretty good. You take the actual model, which is a PB file that is created, and in the end of your training process, and you just actually change it from a 32-bit to an 8-bit, change the numbers from 32-bit to 8-bit numbers, and you actually don't lose a lot of accuracy in that process. You lose something like about 1 or 2% accuracy. So your model is not fully accurate, but 1 or 2 to shrink this model into something that you can push into your device is pretty good. Okay, how much time do I have? Try to do it quickly. Okay. So, how do we push back to Android? So, there is an APK that you can use from TensorFlow Lite. Again, I didn't add here the Gradle information and how exactly to add it, but it's pretty simple and straightforward. We define the graph, which is the actual model that we created now, and we need to also add the label text. Okay, the label is actually holding the labels which we want to identify. We are loading the model into the prediction interface, okay? And we are setting exactly how many number of classes that we have in that we expect to see in the prediction. Now there are 3 things that need to be done here. First, with the feed, which you actually feed the input information for in this example, we used an actual image that comes from the camera. Then we need to run it, which runs the actual image run the actual image information on the prediction model, and then we need to fetch out the results. Okay, and you've got two main properties of the fetch, which is the output name and the actual prediction that you are getting. Okay, just a sec. Okay, so this is actually very simple to implement, and I think it's going to take you about 2 or 3 hours to do that, and it's pretty cool things to use, and it's going to be a good start to implement these kind of things in your applications. Now, I usually give this demo with a real live demo. Unfortunately, I forgot my Dalek doll at home, so I'm going to run it here. This is something I did from my computer today, and you can see here the prediction here, okay? So this is the prediction of seeing the actual Daleks. Now, when it sees the actual Daleks, you see that this jumps up, okay? So, okay, and you can see that it jumps up as soon as the Dalek is appearing in the picture. Everything here runs on the actual device without any connection to a network. So it's not something like no server is involved in this situation. It runs on the application itself. And you can think of how many implementations you can do with this kind of features. Okay, that's my room, so sorry. Okay, so a few lessons learned. First of all, like everything in machine learning and deep neural networks, if you put garbage in as your data, you will get garbage out. This actual model was built on about 200 pictures, which is less than the usual amount of pictures that you will want for creating some kind of a specification for a label. Usually you start with 300, 500, and on. But you need good data, and you need to specify it good. And you need to see that you don't see, mostly in image classification, you don't want to use too many objects in the image that you're using in your data set, because it can identify other things as the object itself. So try to take something very clear. So read about how to handle your data, which is really important. There are a few tricks how to do that. Use the framework that fits you. Most of them works on Python. TensorFlow is very good and scalable, and of course very easy to implement in Android. PyTorch is very good in creating prototypes, because it's very easy to understand. There is something I didn't put here, which is Keras. Keras is a simplified layer of creating neural networks. It's implemented in TensorFlow and PyTorch, so it's very easy to use it, and it really gives you a nice view of how your networks is created. You need to play around. Creating a model is an iterative process. So you're going to play around with your parameters to implement everything till you get a good solution. It's not just create it, run it once, and that's it. You need to play around with parameters, and there are a lot of parameters to play around with, but in the end, you get very good and very reasonable predictions. To all of you that doesn't use iOS, if you're using Windows, try to do these things in Linux, okay? It's very hard to do things on a Windows environment. Most of the example doesn't work. There are features in TensorFlow that doesn't work on Linux, on Windows, and works great on Linux and iOS. And you need to keep learning this area, because this is something that changes all the time. There are many articles that are going out each day, and it's a very interesting subject, but it has a lot of traction and a lot of data, a lot of articles that are published. So you need to keep up with the information that flows in the community. The community is very open to is very open, and I think it's one of the most one of the areas that you see a lot of sharing of information, especially from the Google guys, but also for other institutes, and everything is almost everything is published. Okay, one thing that was published, for example, last week, which I was pretty amazed, is Google have some kind of machine learning algorithm or deep learning algorithm that try to predict which network is best for some kind of for a specific data set, which is actually a machine learning a deep learning networks that creates deep learning networks. Okay, this is called AutoML. It was I think published as a service in about 2 years ago, and 2 weeks ago Google just published the actual code, so you can actually take that and use that today, which is, I think, mind-boggling. Okay, so if you have any questions, or if we don't have time for questions? No, sorry. Okay, so just contact me. This is my Twitter. You've got a QR, and thank you very much.